We will run through an example of one of the patient tasks here now. We've chosen Victoria. She's a female aged 13. Her patient information says she's 13 years old. She started having seizures 5 months ago. Since then, she has had 4 seizures, and it takes days to recover afterwards. She's starting to miss school because of this and now doesn't want to go to school anymore in case she has a seizure. She's finding this scary and is not in control and just wants to go to school and see her friends. Epilepsy runs in Victoria's family as her dad has it, so she's aware of what it is, but up until now has had no symptoms. Her dad's epilepsy is under control and he hasn't had a seizure in 8 years. Victoria says having her dad with her makes her less scared as he knows what it's like and can support her. Victoria has recorded her EEG data and is currently being assessed for epilepsy. If she is diagnosed with epilepsy, she needs a treatment plan to be put in place. Having read her bio, it's important to take a few seconds to think about what she said, and is there anything in this bio that gives you key information that we should think about going forward. Things like she's never had seizures before, this is her first time, how many seizures has she had, and we're trying to remember what the criteria is for epilepsy diagnosis. For example, epilepsy diagnosis, you have had to have had 2 seizures which have occurred more than 24 hours apart. Our job is to determine if Victoria has epilepsy and if she needs further treatment. She's worn an EEG cap to allow us to collect her brain signals. We've used this to create a model of her brain network using mathematics. See if there's any seizures present in Victoria's brain. Change the values of the node and the connections and the noise to see how much change is needed to induce a seizure. Based on this, what is your diagnosis and treatment recommendations for Victoria? So we need to diagnose her, see if she has epilepsy, and if she does, come up with a treatment plan for her. So now we will switch to the epilepsy website, which is here, and we showed this earlier. The first thing to do is select Victoria from the drop-down menu, and this will set her brain network. Once we've seen Victoria's structure here, let's go back to the task and see what the first questions are to do. Use Victoria's brain model to understand her seizures, what may have caused them, and what it takes to cause another seizure. Use the information you have and what you discover to diagnose Victoria. Question 1. Look at the brain network. Notice the connections between the nodes and what direction they're in. So let's do that now. So we've got A, B, C and D, the nodes. A is larger than B, C and D, so this might indicate that there's some activity happening in node A. We've got A is going to B, D is going to B, D is going to A, D is going to C, and C is going to A. So if we notice here, B isn't going to anything here. D is going to A, B and C, so D is having quite the influence here. And then C is connected back to A. So A, D and C are kind of in this triangle loop here, so they're kind of influencing each other. Whereas then D and B are connected and A and B are connected. So A and D are influencing B, and then A, D and C are in this triangle loop here. So once we kind of think about this and have this on our mind, okay, we can try and see maybe B might not be having an influence on the brain, seeing as the arrows aren't going the other way. So what does the second question say? Run the model with this network and look at the output. What does this look like? Well, we just did that actually at the beginning. So this is what the output looks like. We've got seizure-like activity across all of them, and we want to try and reduce this. Number 3, read the note card about epilepsy diagnosis. What other things doctors consider when diagnosing someone with epilepsy? So you can get the information sheets that are attached and handed out here. One of the things we mentioned was that epilepsy, to be diagnosed, like we said earlier, you have to have 2 seizures and they have to be more than 24 hours apart. And this is what Victoria has said in her bio here. So from the beginning, there is an indication that she might be having epileptic seizures because currently her experience is showing and leaning towards that. So number 4, based on the information we have and the brain model, do we think Victoria has epilepsy? So she's had 2 seizures, she's had 4 seizures, more than 24 hours apart, and there's activity in her brain here. So I'm going to go forward and say yes, Victoria is very likely to have epileptic seizures. So we're going to diagnose her with epilepsy, and now we're going to move forward with her treatment plan. Number 5, remove one of the connections and note down which one and run the model. Write down any changes you see, if any. You can decide as a class when you do this what connections we're going to remove first. I'm going to suggest maybe we remove A to B, As we said before, B isn't connected to anything in the other direction. So potentially, if we remove the connection from A to B, maybe the seizures and the seizure activity in B might go down. That's my prediction. You can make a prediction now as a class. You can see who might think otherwise. Do people agree that the seizure activity in B might go down, or do you think it's going to go up? What do you think is going to happen? This is the kind of conversation we want to encourage as we're doing this along, and see, I think having predictions and doing it as a bit of a challenge like that is quite a fun way to engage people along the way. So I'm going to remove the connection here by right clicking and clicking a remove line, and then I'm going to run. And while I'm doing this, we can wait and see what's going to happen and see if just B is going to change or if any of the other seizure-like activity is going to change. But remember, as it runs, it's always creating a new output. It's not exactly the same every single time. So we see here now that actually B has really gone down. So this suggests then that A was having a big influence on node B. And by removing the connection between A and B, we've stopped the seizure activity in B. So the seizure activity isn't originating in B, and it's actually coming from A. So that's really interesting. So now why don't we have a look at, and then we can see actually what else is going on. And you may be able to do this in a different way. You can follow this, you can add the connection back in, or if you want to, you also have the option to kind of remove it and keep it removed and finally reduce all the others. If we add that back in, now let's remove another connection. Why don't we go from D to A? Let's remove that and see what happens. Again, you can make predictions now of what you think is going to change. By removing D to A, we're actually seeing a lot of difference here. So C has decreased and D has decreased. So again, A seems to be having an influence on C and D in this case. So again, this kind of alludes that A might be the source of the seizure activity, and by removing connections, this actually decreases seizure activity in other parts of the brain. Another connection if we want to. By removing C to A, C and D is still quiet, there's no more seizure activity here, but A is still having quite a lot of seizure activity. And you can continue this process of removing them, you can add them back in if you like, but if we remove all lines, for example, what is going to happen? You can do a prediction here. What is going to happen? There's no connections between them now, so what do we believe is going to happen? Is there still going to be seizure activity in A and B? Just A, because we think A might be having the impact of the activity? So we see here now that B, C and D have now gone quiet. There's no more seizure activity here, but A, even though there's no connections between the brain or the nodes of the brain, A is still having seizure-like activity. Therefore, A must be the source, and this portion of the brain must be where the seizure activity is occurring and influencing other parts of the brain. So what we found is that node A is one of the sources of the seizure activity in Victoria. Now, if we go back to the questions, from changing the network structure, what have we discovered? So what we have just discovered that A is part of the problem and the cause of the seizures, and that removing some connections can remove those seizure activity in other parts of the brain. Now, what happens if we increase or decrease the excitability of node A? So if A is the source, if we turn down A, will that make a difference? So what we're going to do first is we're going to reset the network structure back to the original before we start changing any of the other excitability values. So now that we've reset the structure, we're going to click on the tab at the top and we're going to go to the sliding scale of node A. So at the minute, node A is on 0.8. And now you can ask, how much do you think we should decrease it by? Or we can increase it. You can decide what you want to do here as the first example. I'm going to say, let's decrease it by 0.2. So if we go down to 0.6, you can do this at any increments you want to at the beginning. You can go all the way down, you can go halfway, you can go 0.1, whatever you like. Click apply. So we've reduced it by 0.2. Again, make a prediction. What do we think is going to happen? Is the seizure activity going to increase? Is it going to decrease? Is it going to decrease in the others, A, B, D, and C? So we've decreased it by 0.2, but there's still some activity here, maybe slightly less than previously. And now if you want to, you can go back in and change it more. Let's go all the way down to maybe 0.2, for example. What influence does this have? Going down to 0.2 has decreased the seizure activity quite significantly. There's still a little bit, but that's had such a big difference already. And even that's change, even if it's not got rid of everything completely, that change might be really significant for the patient. So we could aim to bring it down to 0.2. But for example, if we bring it all the way down to 0.01, what happens then? When we've reduced it the maximum we can reduce it, will there still be activity there or not? And we'll find out now in a second. By reducing it the maximum amount, a lot of the seizure activity is gone, but there's still a little bit active here. So reducing the excitability will seriously decrease the seizure activity of the person with epilepsy, of Victoria in this case, but it doesn't completely eliminate it. But this is an improvement, and this is increasing the quality of life of Victoria. So this is something to note. Reducing the excitability is one way for us to go in treating Victoria. Now, question 9. What happens if you increase or decrease the strength of the connections? So we'll go back here. We'll bring the node excitability back to what it was, 0.8. Now, if we look at the strength of the connections, it's on 0.1. If we, again, you can play around here, do a vote as a class. Do you want to increase it? Do you want to decrease it? How much? Let's, for example, decrease it to just, let's go 0.01 or 0.02 now, just to see. Again, make some predictions. What do you think is going to happen here? And it's kind of just about the process of going through each of them, following the questions, changing each individual value to eliminate and deduce what is the cause, what values, what variables are the important ones that reduce the seizures. And once you find those, you can align the treatment option to those. And it's about encouraging this discussion, making predictions, turning it into a game. Do you want to go higher or lower? These are the things that really can keep the students engaged, particularly through this first example, as we're kind of showing how it works and getting them to think about the questions they should be asking themselves when they're running the task on their own or in their small groups. So decreasing the strength potentially has had a little bit of an impact on B, C and D. A looks kind of the same. It looks like there's fewer seizure-like activity in B, C and D. And you'll notice as well there's just some features here where the lines and the connections of the arrows, they get thinner when you decrease the strength, and they will get thicker when you increase the strength, just as a visual aid. So decreasing the connection strength can have some effect, but it doesn't really eliminate the seizure activity like the node excitability did. And finally, question 10, what happens if we change the strength of the noise? Again, same thing, revert the values back to their original 0.1, and let's decrease the noise. Let's go 0.1. And there's, in the information packs and the patient sheets, there's the original values and network structure there as a reference, so you don't have to remember these numbers. They are always there at hand. So reducing the noise to 0.1 completely eliminates everything. Let's even increase it a little bit. So again, reducing noise clearly has some huge effect on the EEG output. So these are things to consider. Excitability and noise seem to have the biggest impact on Victoria. So now we're on to the treatment bit. We've kind of deduced what's going on in the brain, what are the key points and variables that are impacting the seizures. So now we want to treat Victoria. And our treatment options are monitoring and do nothing for now, medication or surgery. And these are big things to consider. And again, thinking about Victoria, thinking about her bio, and she's a 13-year-old girl, so what's important to her? What are the key things about making her life better at this point and in controlling her epileptic seizures? So you want to remind yourself first and think about this and come up with some key things we want to do to help Victoria. Then moving on to question 12. There are 2 medications available. Test each one and see the effect. Start with drug 1. Start with a low dose, what happens, and then increase. So let's revert the noise back to the original. I think it was 0.6. Let's do that. Now let's go on to drugs 1 and 2. If we click show more here, we'll reveal the drug. So let's turn on drug 1 and let's start with 25 milligrams. Did you notice anything there? Drug 1 decreases node A by 0.5. Now you can try this and see the effect, but as we saw earlier, decreasing node A by the maximum possible had the biggest effect. So maybe you can always skip this step and you can go to the maximum. 100 milligrams decreases the node A by 0.2 in total. And we can see what effect this has. Does it have enough of effect to help reduce her seizures? We might have to do combinations of drugs. We might have to see if drug 2 alone will impact it. Or if not, we can see if there's any other therapies we can look at. So the maximum dose, 100 milligrams of drug 1, decreases the seizure activity slightly, but maybe not enough. Can we do better? So let's turn off drug 1 and let's turn on drug 2. What does drug 2 do? Drug 2 decreases the noise. And now, as we saw earlier, the noise had the biggest effect. So if we do potentially the maximum dose, 100 milligrams, that decreases noise to 0.2. Now, this is a way up as well that doctors will have. Is it worth going for the strongest dose originally? Can you get away with having a lower dose that will have enough of an impact that it might remain some seizure-like activity, but it might have less side effects and things like that? So here we can see that 100 milligrams of drug 2 completely removes all seizure activity. But actually, if we try 50 milligrams, is that enough? Is that enough for Victoria to get by on? Because often people, their experience of taking medication is that they can be on it for a long time, and sometimes the effects can wear off as well. So sometimes starting low will increase the longevity of the drug for you. So 50 milligrams also decreases the seizure activity. It's a little bit noisy, but it still might be good enough of a job. Maybe even let's try 25. You can actually do this the other way around. I jumped ahead here and went for the maximum, but you can work your way up and actually see this. But it's kind of nice to see maybe backwards that way, seeing what the maximum effect is and then working down to see if a lower dose will be suitable. And their side effects is a thing that we need to consider too. So 25 milligrams leaves some seizure activity. So I would say here potentially 50 milligrams is enough. And there's a little information tab here in this information sheets which shows you the side effects of these medications. So for this medication, drug 2, it says take 2 times a day, morning and evening. Is that reasonable for a 13-year-old girl to do? Will she remember that? It's not a 4-6 times a day medication. That might become unfeasible. And the side effects, headaches, feeling drowsy, aggression, irritable, things like that. Is it safe for her to take? So we need to think about these things as well. Is it realistic? Are the side effects okay? Should she trial it first and see how she gets on? So my recommendation here would be to give Victoria 50 milligrams of drug 2. And going on now to question 12, we did that. What do any of the drugs have effect? Read the notes on the medication. Do the benefits outweigh the side effects? And then what is your final treatment recommendation? So this is where the students can write on their task sheet and fill out all the information pieces there. What's their final recommendation? Why have they chosen it? And they need to really kind of support themselves and give all the evidence of why they've said that. Why have we chosen 50 milligrams instead of 100 milligrams? Why not 25 and things like that? And taking into consideration always the patient experience and what we can do to increase their quality of life. So this is an example of how you can do this as a class first. Introduce the questions, introduce the predictions of what you think is going to happen, and now the students can go on and do this in their individual groups, and they've got more of an idea of how to use the website and then the questions to ask themselves.